Here are the solutions to problems 8, 9, and 10 from the Kinematics review. Number 8, a baseball pitcher throws a fastball at a speed of 44 meters per second. That's going to be the final speed of the ball because before he throws it, it's not moving. The initial speed is going to be 0. The acceleration occurs as the pitcher holds the ball in his hand and he moves it through an almost straight line distance of 3.5 meters. We're going to calculate the acceleration assuming that it's constant the entire time or uniform. So A is our question mark, T is the thing we don't have and don't care about, so I pick the equation without time in it. That's Vf squared equals V naught squared plus 2AD. I'm solving for acceleration, so I'm going to subtract V naught squared over to the left first. That's why I've got Vf squared minus V naught squared in the numerator, and then divide by 2D. That's why it's down here in the denominator. I plug in my numbers, and I get 44 meters per second. Square it, minus 0. Doesn't matter if you square it or not, it's still 0. Divided by 2 times 3.5 meters. That's going to give me an acceleration of 276.57 meters per second squared. Number 9, a cheetah can reach speeds of 32 meters per second. That's going to be a final speed because we're assuming the cheetah starts from rest, so initial speed 0, and has an acceleration of 10.5 meters per second squared, so that's our A. How much ground does the cheetah cover before reaching its maximum speed? Otherwise, what is the distance that the cheetah is going to go before reaching a speed of 32 meters per second? We're going to pick the equation without time in it because we're trying to solve for D. So that's Vf squared minus V naught squared equals V naught squared plus 2AD. We're solving for the D, so I'm going to subtract V naught squared over first. So Vf squared minus V naught squared is in the numerator. Divide by 2A. That's why it's in the denominator. And I plug in my numbers. 32 meters per second, square it, minus nothing, all divided by 2 times 10.5 meters per second squared. That's going to give me an answer of 48.8 meters, or how far the cheetah will go before reaching its maximum speed. Number 10, the driver of a car steps on the gas in order to pass a slow driver in the right lane. The driver was initially going 26 meters per second, that's the initial speed, and accelerates at 2.5 meters per second squared for 4.5 seconds. How fast is the driver going now? So we want to know the new final speed for the car. D is the thing we don't have, so we pick the equation that does not have D in it, which is Vf equals V naught plus AT. It's already set up for the variable that we want, which is Vf. We can just plug our numbers in. So Vf equals 26 meters per second plus 2.5 meters per second squared times 4.5 seconds, giving us a final speed of 37.25 meters per second.